Hello, this is Greg Allison with Green Gregs coming to you on the 23rd day of November 21. Time on deck is 19:08 hours Central Standard Time. And I've got special guest tonight, Steve Curtis. And we're talking about microgrids using small modular nuclear reactors to secure our grid in case the power goes down. And I've got some delays here. All right, so that's what we're going to be covering tonight, my friends. And the video might be a little jumpy because I got another video that's apparently still compiling, so my memory might be a little constrained. So, ladies and gentlemen, I give you Steve Curtis. Steve, tell us about yourself and how these small, just a little bit, just an introductory, why you think these small modular nuclear reactors can help save our power grid.
Okay, my background is a double-E undergrad, and I've got a health physics master's degree, which is radiation science, basically. I worked for 15 years in the nuclear emergency search team as a technical team leader. And I have some background in the military. I was a military officer. And for the last 3 years, I've been looking at the idea of how to use small modular reactors to the advantage of us regular citizens and for power supplies. And so as we worry more and more about the national grid because it gets older, there's cybersecurity issues, there's solar flare issues and EMP issues that we all worry about. Then we want to find a way to help secure the grid a little bit better, and one way that's not very expensive. And one of those ways would be microgrids with small modular reactors that control a small area, but can tap into the national grid if necessary. And those have the advantage that you can control them locally. It has any one business can run any one microgrid once the small modular reactor technology comes on board. And actually, small modular reactors can use nuclear fuel as a power source, which is a real advantage as well.
Oh, very good. So we're also talking about the use of burning spent fuel rods, the spent fuel, right?
Correct. Yep.
That's one of the things that worries me the most. And for those that haven't ever watched my channel before, I cover a lot of prepping topics like this, things that we need to be aware of, and solutions other than just ride and duck and cover and crawl under a rock and have a bug out location, which is important to have, and bug out supplies. But I also cover things that we might do to prevent these problems or to mitigate them should they happen. And that's why I've got Steve on as our guest tonight, is because if we develop these small modular nuclear reactors, they're going to be safer, and he can explain that to you, and they can get rid of some of our problems like spent fuel. And we could also use them to have backup power for our nuclear power plants so that they don't go into meltdown, and so all the spent fuel rods or the fuel rods that send the fuel cooling pools don't go up in smoke, because there's a lot more radioactive material there, and it's not in a containment building than in the reactors. Now, some of it, over time is not as hot, but there's the amount of fuel there is mind-boggling. It's a very dangerous thing that we need to prevent from happening. So to get more videos about this kind of stuff, subscribe to my channel, bang the update notification bell, and click all. But because I also bring you videos not only about prepping, but things that you'll need to know, especially if our grid goes down or if we get into a conflict in the world, like how to grow a victory garden, how to survive from the weeds and the trees. But one thing you can do, if you grow your own garden, especially like the wintertime here, if the grid goes down, you're gonna want some greens to eat, and you may not be able to go to the store and get them. So one thing you could do is go to True Leaf Market. True Leaf Market is great because they have heirloom seeds, and you can get all the supplies for growing microgreens. Watch my videos on growing microgreens. I got a trailer I grow them in. I sell them at the farmers market, and you can right now they got a special 15% off up through Black Friday, and all you got to use is a special code, which is hang on a minute. You got to say while it lasts 15, while it lasts 15, and that'll get you 15% off of the supplies there. So you can go to True Leaf Market. It's an excellent source for your seeds, and check it out. And there'll be a link below later after I post this video. And it's also in many of my other videos that I upload, not the live sessions. I don't usually put links on live sessions. But anyway, so Steve, tell us why these small modular nuclear reactors will be safer.
The primary reason is, first of all, they're smaller. They're anything from 300 megawatts and below essentially is considered a small modular reactor. Our current light water reactors that you guys all know about are about a gigawatt. So a little more than three times more power. So actually you're trying to really get rid of less heat. You're using a smaller heat source, which makes it easier to control. But the designs of the small modular reactors are specifically made to be something they call intrinsically safe. They're safe no matter what happens to the reactor, no matter what happens to the outside world, because they have their own internal capability to cool themselves down to a point where they're not going to melt anything. There's a lot of different designs. There's a lot of different ways they make to do that. And it's kind of an exciting technology. So that's the reason they're much safer, is because they simply can't melt down like a light water reactor. They're really, the different designs allow different applications. You can go all the way down to 1 megawatt, which you can see may be really handy if you're trying to power something way in the middle of the wilderness or in the middle of the desert. The military is very interested in this because 1 to 5 megawatts is sort of their power range for a base or a forward area in the battle. And having their power generated locally saves them hundreds of lives, because in modern battle, the people are dying on the logistics train, on the supply train that comes in. That's where they're dying. So if you have to bring less water up or less fuel up or to the battle area, you save a lot of lives. And that's why they're really interested. The military is very forward looking on this. They have narrowed their search to 2 small modular reactors, and even chose Eilerson Air Force Base in Alaska as the place they're going to test these. So there's a lot of advantage to small modular reactors besides just being a very compact local power source that can actually drive free enterprise. You can actually have different companies buy a reactor and supply a local area with power, and you can have competition back in the electricity market, which, as you know, is the way to get a lot the prices down. If you want prices down of electricity, you need to have competition. So there's a lot of advantages to these things, Greg.
Okay, one of our chat room participants, Monashi Preppin, who's another prepping guy, they asked this: so smaller is less waste, but more of them, what happens to the waste? You've talked about reprocessing spent fuel rods, so how do you deal with the waste? What's
Good
your
question? The truth is right now that nobody's thinking about what to do with the waste. To say we're right for the large reactors, it's very safe where it is. You've heard a lot of hype about being dangerous and sitting around in communities, but it's very safe right where it is. I can go into that in detail if anyone wants to later, but I'll make that statement. A lot of the designs for the next small modular reactor generation will also produce more waste. But the project that I want to get busy on is that a small modular reactor that can actually use the waste to make energy. So we take the waste we already have, instead of burying it, there's 30 times the energy left in a spent fuel rod than it used when it was in the reactor. It doesn't make sense to waste that. Fast reactor technology is here today to do it. It's not on the market, but it's available and it's well understood. So our proposal is to move forward with that prospect. But the truth is, nobody has thought what to do about waste, or they have thought about it, but they haven't come out with a real solution right now. But we shouldn't panic because it's safe where it is. It's not going to hurt anybody where it is.
Yeah, okay. See, we built a huge nuclear waste storage facility in Yucca Mountain. Utah let us go in and put an ever last thumbtack in that place, until they got to the point of moving the fuel. Then they said, oh, no, you can't bring fuel here. So they liked us spending money there, but they just didn't want us to use it. So that was kind of a double dealing, in my opinion. But we've got to find ways to process this fuel, do something with it, get rid of it. That's one of the key things about it. But one of the other good things is that I worry about right now, we're leaving it all of these spent fuel, except the stuff that dry cast. Once it gets on up to dry cast, we dry cast it. But the dry cast fuel and the hotter fuel is still in the cooling pools at these nuclear power plants, which is in a side building, or in Japan, they had it on top of the reactor buildings, but it's in these side buildings that have basically just a sheet metal roof, and it has a zircaloy cladding that burns on contact with air. They got about 20 foot of water on it, but they evaporate about 160 gallons of water per minute. and you've got to keep that pumping. And with the grid down, all you got is backup diesel generators. No, a nuclear power plant doesn't make the power to run itself, which is contrary to what a lot of people think. But that's absolutely true. And it can load balance and a lot of other things. It just don't work that way. In fact, it takes a power plant to start up a nuclear power plant. And that's the beauty of these plants is they could, one, provide backup power to keep all the cooling pumps running in the reactor and the spent fuel rod pools, or I shouldn't just say spent fuel rods. There's actually rods in there, hot rods waiting to go in to the reactor. The cooling pools is more accurate description of those pools, and also has the capability to black start that power plant when it's all the way down. So there's, and it helps augment the power. It gives you a local microgrid. So you might elaborate on that a little bit, Stephen.
Let me step you through how the fuel system works. The rods that you mine uranium is about 0.7% of the good uranium that fissions. We need to enrich that. That's a pretty straightforward process. So they enrich it and they make new fuel rods. You see the big fall 15-foot assemblies. You've seen pictures of them, I'm sure. That's the product that comes out of that. You can stand next to that and it's not dangerously radioactive at all. In fact, all the radiation that comes off of that is stopped by the zircaloy coating. And by the way, they have something called accident tolerant reactor fuel now that they're actually putting in reactors that doesn't use zircaloy. It uses more of a silicon carbide kind of a material. So though they're actually looking at that problem as well. So once it goes into the reactor, it stays anywhere from 3 to 5 years, depending on how much you burn it down. And they pull it out and they put them into the spent fuel pools like Greg described. And they sit there for about 5 years. And the reason they're in the pools is because they're both radiologically and physically hot. And so an elegant way to do that, if you put these under about 25 feet of water, it stops all the radiation. And if you circulate the water, it takes the heat away. Okay, well, radiation is energy, heat is energy. So we're actually, we just don't use that. We haven't found ways to use that yet, but we could. And there's ways that small modular reactors can actually use what they call process heat to actually do other things. But we don't do that now. We put it in the pools. And what happened is they promised they'd take this reactor fuel in Yucca Mountain. And because of a lot of politics in Nevada, and I lived through it for 30 years. I lived in Las Vegas for 30 years. I went to my first Yucca Mountain meeting in 1981. Never worked for the project, but I've always been an advocate that Nevada should take this fuel and use its big business. But they decided to spend their money and scare the rest of the world, which we could talk for hours on end, but I won't. So then when it comes out of the fuel pods after about 5 years, and they were running out of room because in 1999 they're supposed to take it and they didn't. So now they have a lot more than they thought they would have to put up with. And in fact, the government's paying about $2 million a day for them to keep that spent fuel on their sites. But they take it off after it comes out of the spent fuel pool and they put it in dry cask storage, which is a huge 30-ton concrete container. And it's well sealed. And the reason they can do that is because after about 5 years, the radiation level has gone way down and the heat production level has gone way down to the point that air can cool it. And so when they put them in these dry cask storages, that's what they're counting on, is the air cooling to happen. And if you see pictures of them, people can walk right up to the edge of it. They've been, the one at Connecticut Yankee's been sitting there for 20 years behind a chain link fence and nobody's bothered it. So it's really not dangerous stuff. But when you talk about the black start idea of a small modular reactor, it's a very good concept, because one of the Achilles heels and the main Achilles heels of a light water reactor is to kick the heat off of it. Once you got to take the heat off of it very quickly. So it produces a lot more energy, but you got to take a lot of energy off of it. And when Fukushima, what happened is they lost offshore power. Well, you guys all know why they lost offshore power. And in 3 Mile Island, a pump failed. Okay. And there's a few other human factor things, but it's important to remember that the reactor did what it was supposed to. 3 Mile Island didn't hurt anybody because the reactor safety backup features worked. Fukushima did not hurt anybody from the reactor failure process of it. And so that's the idea of safety, is if maybe the reactor melts down, but it doesn't hurt anybody. Okay. And that's the case in both of those instances. But what a small modular reactor can give you, it can keep running through all of that stuff. And if it keeps running, then you can supply it with offsite power, because it creates its own power and sends it out to the world. but the things that are operated like pumps and everything are run off the offsite power that comes in. And so when you lose offsite power, you lose your pumps and you lose your cooling capability. And if it goes to a great, like it did at Fukushima, if it goes too far, it'll melt the core. Well, in Fukushima, the backup was diesel generators, which worked fine and would have taken over if the tsunami hadn't come in and took them all the way. And behind that, they had battery backups, which actually underwater, they worked for 8 hours. That's not nearly enough to handle what they needed to handle in that situation. So if you have a small modular reactor, it can survive those types of disasters. They're built underground. If you're smart, you'll put your cabling underground. It gives you a little more protection from external insults. If you get a big enough EMP, it ruins everything. But if you're underground, it'll survive a lot more EMP pulse than any other a reactor would if it's not covered underground. So those are the things you got to think about. But if you keep a reactor with offsite power going, the pumps will keep going. And there's a lot of backup for those pumps too. And so when a reactor stops, all of, you know how a fission works, it's splitting atoms. When the reactor stops, and this worked at Fukushima and this worked at 3 Mile Island, all of the fission stops. All the molecules stop dividing and producing energy, but everything that's in there, it still keeps decaying and producing heat, radiation and heat. And so you have to keep that cool down to a level until it cools off enough that it's not going to melt. And the zircaloy has to be, talk about the spent fuel pool, zircaloy has to be about a certain temperature before it react. So if it's sitting in the spent fuels for a while, they'll be cooled down enough to where that temperature won't cause the reaction. And the only reaction only happens if air hits the zircaloy cladding at a temperature that's, I can't remember what the temperature is. It's around 1700 degrees. So there are backup systems all over the place. But the point is, if you have offsite power coming onto a site, these things won't happen.
Right. So, but if you have a nationwide grid down, the problem is at some point you can't get the backup fuel to run those backup generators that we currently use. We have a lot of redundancy for a local regionalized failure. We got plenty of redundancy, but if we have a nationwide grid down, we got serious problems, and the whole supply chain falls apart that keeps that plant running. Right. And that's where we run at risk with these fuel rods. How long, Stephen, how long does it take for those fuel rods to cool down enough where they won't evaporate the water, or that if they do evaporate the water, they won't burn on contact with air? Do you have any idea?
Well, it's certainly after 5 years, they're cool enough, because that's when they take them out and put into dry cask storage.
Yeah, I get the 5-year part.
But the way they decline is on an exponential curve. So they go down faster in the earlier times. They go down a lot faster in the earlier times. And I think 2 or 3 years in that pool, and they probably wouldn't spontaneously react with the air. I don't know that exactly, but that's my guess in general. But it's a lot less time than the 5 years they're in there. So all the spent fuel rods in the pool will not react and have a zircaloy meltdown. All of them in the reactor will. The reactor runs at a much higher temperature than that. So you're for sure having a meltdown if you contact air with a zircaloy at that temperature. And then you evolve hydrogen, and that's what we saw in Fukushima, was hydrogen explosions. They invented the hydrogen that evolved in 3 Mile Island, but they didn't invent it in Fukushima. So everybody who saw those big explosions they put on TV, that wasn't a nuclear explosion. That was just a hydrogen combustion explosion, which really is innocuous compared to what they made it out to be on TV. So that's the answer. The answer is there are dangers, but there are a lot of backup systems that can help it. And small modular reactors could be better for that. And if you don't damage the reactor, you're right, you need to have offsite power to restart the reactor. So small modular reactors could provide that offsite power. And it's also, like I said, a very valuable power supply tool. And if we use the spent nuclear fuel, it's 100% clean because we don't have to mine it. It's already sitting there mined. It's 100% domestic because they're sitting on all the reactor sites in the country right now. And it's much cheaper, because when they mass produce the small modular reactors, they're going to build them in a factory, kind of like you do a refrigerator or a car or an air conditioner, and ship them to the site and install them. They're not going to sit on the site with massive concrete installations and everything. They're far simpler to install and far cheaper to install. And we all know that if we have a mass production process, they're cheaper. But I'll tell you, the reactors in China are about the cost of slightly more than the cost of a coal reactor, maybe $3,000 a kilowatt. And the ones in Russia are about $3,000 a kilowatt. And the ones in South Korea about $3,000 a kilowatt. The one in Vogel they're complaining about is up to about $8,000 a kilowatt, mostly because of delays caused by government regulations. So there's a story out there that's not being told. Nuclear is a very good way to produce energy, but small modular reactors and the next generation of nuclear reactors are much better. But you're right. Somebody's got to face that spent nuclear fuel issue and face it head on. We're not in imminent danger, but the government promised they'd have a solution for it. And now here we are 4 decades later, and they still don't have a solution.
Yeah, no kidding. And we should have, but it's all politics. I would submit that the people in Nevada are actually more at risk from the spent fuel rod pools in other states than they would have been if we'd have put those casks in their mountain, in Yucca Mountain. But that's another story. We just need to be able to maintain enough grid so that we don't have to worry about all these things going up the smoke and flying us all over the country. A lot of preppers think they're safe because they got all their supplies and they're off grid. But as long as we face a situation where these nuclear power plants and their cooling pools can go up in smoke, we are in grave danger across the country and the world. And we've got to find a way to deal with that. And that's what I like about these. Now, somebody in the chat room, Jesse Mills, asked a question. She said, what about someone tampering with it to make a dirty bomb? I guess she's worried if we have so many reactors out there, how do we have enough security that somebody can't get into this material and use it to make a dirty bomb? What would be your suggestion for that?
Well, now you're hitting in my breadbasket. That's what I did for 15 years with the DOE. And here's the idea with the spent fuel. And let me step you through a little scenario. You're a terrorist. Your idea of a terrorist is to be as cheap and disruptive as you can, because you don't have much money, you don't have much sophistication, and you want to make something that makes a statement, but is fairly inexpensive to make happen. So these rods are well protected by SWAT teams in the reactor itself. And even an individual fuel assembly, which is where they're kept, weighs about half a ton. A cask weighs about 30 tons. So if you're worried about casks getting hijacked, you got to put yourself in the mindset of a terrorist. What are you going to do to disrupt something? Are you going to go out somewhere where there's a cask and a highly guarded area and try to break through it, or load it on a truck and take it away? And if it's a dirty bomb, the idea of a dirty bomb is that you want to disperse it as far as you can and scare people. So how are you going to get spent fuel rods, which are the consistency of ceramic? They're inside a zircaloy tube, they're inside a fuel assembly, and they're inside a concrete cask. That's a daunting problem for terrorists who really are working on a small budget and don't have much sophistication. And so I just like to ask her what her scenario would be that a dirty bomb could work. I can't imagine it myself. And I've worked in this business for 15 years and on how we stop that, how we counter terrorize those things. And that's frankly nothing we worry about in that world. It just doesn't seem plausible that people can try that.
Well, that's why we have you on the channel. A lot of people don't realize that. And that's why they're asking the questions, because, the general public really has very little knowledge about what a nuclear power plant is, how it operates.
Yeah, you're right about that.
They think of nuclear power plant runs itself. They don't conceive, and they will even argue with me about the notion of the outside power requirement to run a nuclear power plant, because it just doesn't make, to them, walking around sense. But, when you're an engineer working these things, you can understand these things. But, so that's why we have you here, is to explain these things.
Right.
Now, what I might mention, if somebody wants to make a dirty bomb, the obvious place to go to is medical supplies, where they use radiological materials for medical purposes. That stuff's a lot easier to get to. What do you think?
Well, or university. Their universities aren't as well guarded as that is, but the fact is nobody's tried that yet. And like a lot of terrorist situations, we can all sit and think what we'd do if we were terrorists. And if we can think of it, they can think of it. But a lot of these haven't happened. And my scariest scenario is New Year's Eve on the Las Vegas Strip. 300,000 people crammed in shoulder to shoulder, and yet it hasn't happened yet. And that's because we have an amazingly good law enforcement group that nips a lot of these things in the bud, and because basically terrorists are really stupid. Okay, so there you've watched the James Bond movie. You don't have those. Those people aren't out there. The James Bond evil guys are not sophisticated, rich, smart, large armied people. They're people that live in apartments waiting for them to go execute a bomb or something like that they're told to do.
Listen, Steve, that thought has occurred to me a million times, and I'm so thankful that most criminals don't have the intelligence that a lot of us engineers have, or they would be really dangerous. I mean, Steve, I built rockets. I mean, serious rockets, a lot of them in garages. This is a rocket motor that's built in a garage right here. Now, a rocket like this against an armored vehicle would make mincemeat out of it. And I could come up with all kinds of scenarios to take a few $1 million from an armored vehicle if I was so inclined, like probably a dozen different ways or things like that. So, but I wouldn't do that. And it's true of I know tons of people that could do these kind of things and come up with ways to take stuff. Now, maybe I could write a good movie script and make a movie out of it or something. That'd be the real way to make money with some idea like that, like Ocean's 11, where they had the last version, they used an EMP device, to take down the power in Las Vegas.
That's right.
Money there. But, fortunately for us, most criminals just aren't that smart. They play Rambo. They got to stand up with bang bangs, which we got to be careful what words we use on this channel. I call them nugs on this.
Yep. Gotcha.
We got to use code words or this platform will kick us hard. But but I'm thankful that these criminals are just they're just not that smart. Unfortunately, they can do a lot of damage with the things at their disposal, such as an automobile. That's a weapon of mass destruction. A lot of people don't realize that. An automobile can be an awful weapon, as we've seen recently. Just horrible kind of things that people can do without a whole lot of imagination. But we just got to be aware and vigilant in our society. I tell everybody in my channel they got to keep their eyes wide open and head on a swivel. And that's why we bring them these stories. So let's see. Somebody says, if you want to talk nuclear, get Gordon McDowell on. Well, we can talk plenty of nuclear here, guys. So we don't have a problem with that. So go ahead, Jesse. Tell us the advantages of having microgrids. Now, we haven't really got into that.
Okay. The microgrid is that me? It's a microgrid is a very small reach for the reactor. The national grid covers the entire United States one way or another. There are some huge grids like Texas has their own grid generally and things like that, but they're all connected to the bigger grid so they can borrow power back and forth and send it across. And so one small problem in one part of the grid can cause a chain reaction where millions of people could be out of power. It almost happened in Texas. In California, routinely happens. They do it on purpose there. They shut off the power when the wind blows because they got sued for a fire. So there's a lot less security of you sitting in your home and having your power all the time, which we all want, we all need. I mean, there's nobody that can survive very long in this country without power, although about half the people in the world do every day. So the idea of a small modular reactor is it's very well secured, very safe, and we'll just keep on running. Okay, we'll just keep on operating through hurricanes and tornadoes and whatever power you have. Now, if you don't have a lot of what happens in hurricanes and powers is the power delivery system blows down. So it doesn't matter what reactor you have there. If you can't get the power out, it's not going to work. So in a small modular reactor, you have more of a direct interface with the different customers. Let's say you have a city of 9,000 people and you put a small modular reactor in it. You'll attach it to the grid because if you're getting grid power and it's cheaper, that's fine. But if the grid goes down, then you can pull it back into your small modular reactor and keep all your people that are connected directly with you supplied with power as long as their power system doesn't go down. I think what you'll see is a lot more underground power. That's going to take a long time to transition. But when we move into it right now, we start with the power system you have. You can go into wherever the power comes into the grid for a city. You can put a reactor right there, tack right into the transformer system that's right there and supply the city. It's the tricky part of that is getting the reactors to start building. And the only reason they're not building reactors now in great droves is that people are afraid of it. And therefore congressmen are afraid of it. And their technique to stop it is to put huge regulations on it. Nuclear power is the safest way to produce power, bar none. It's got the best industrial safety record of any power production business, including wind and solar. And so if you really think of safe, look at the statistics. The statistics will tell you nobody has died from nuclear power in the United States in the 6 decades that it's been operating. So what's happened is we were big guns on nuclear in the 60s and 70s until 3 Mile Island happened. And the big PR guys saw an opportunity to eliminate nuclear from competition in the energy business. And that's big money. It's in 2016, our energy bill in the United States was $1 trillion. That includes gas and oil and cars and heating oil and electricity, but that's a big business. And so there's a lot of people interested in getting a piece of that business. And if they can knock off a competitor by getting them out of the business artificially, well, more money for them. But guess what? Worse for the consumer. So we need a lot of competition in the electricity business, and this could bring it to its heels. So if you put these small modular reactors in different areas, locate them, it has the advantage that they can supply their local area very efficiently. And these things, the least they need to be refueled is 7 years. Some of them will go 30 years without refueling. And they're very robust, and they work under a lot of tough conditions because, like I said, they're built underground. And then if the national grid goes down, then you can disconnect from the national grid and supply your power to your local area. You can also supply emergency power to other areas, like an Air Force base may be able to supply emergency power to a local city if that happens in their watch. And a lot of people don't think of this at all, but did you know that they had nuclear power backup when Katrina happened? A lot of people don't think about that. They had nuclear power because the aircraft carrier that sailed in there to help them was powered by a nuclear reactor, provided them auxiliary power during that crisis. Well, why do you want to take down a whole aircraft carrier group to have a mobile reactor? Russia has them now. Russia has mobile reactors. They'll, on a barge, they'll pull them up the river and they'll supply a town when they need power. So we're way behind the technical 8 ball on this, and we really need to catch up with the rest of the world. And again, the reason it's not happening is because people don't understand just what you said. They don't understand, and they fear what they don't understand. And they listen to people telling them things about what they don't understand that really may not be completely true, or certainly if they are true, are not a real problem. So that's my pet peeve with all of this. And I'd love to get, and the other thing about a small modular reactor powered by used nuclear fuel is it doesn't have to be behind, no small modular reactor has to be by a big water supply. So any of this can be done anywhere in the United States. It doesn't have to be by a big river or an ocean or somewhere like that. Now, I'm not saying the light water reactors are a bad idea. They've done a heck of a job for us over the last 6 decades. And they provide 20% of our power in the United States right now, and over 55% of our clean power. So the guys who want to take them all down and do away with them are really playing with fire. They took San Onofre. They wouldn't let San Onofre come back up. And so that's taken 2 gigawatts of power off of their grid, and it's being supplied by natural gas plants. There's not enough wind and solar to back it up. And then they're talking about taking Diablo Canyon down. If you look at Germany took down almost all their reactors. They're going to supposed to all be down by 2023. They have the highest cost power and the dirtiest air in Europe, even though they're talking about wind and solar and everything happening there. I lived in Germany. I don't know why they even talk about solar. I was there I think the sun comes out 9 or 10 days a year. And so why would you want to have the place solar power in the Southwest where it's all the time? It's only about 25% effective when the sun does shine all the time. If you put it someplace where it's cloudy all the time, it maybe goes down to 10%. So they may say they have a gigawatt plant, but they only have a 100 megawatt plant. So you really need to look at all these statistics, and because they're free, because they're subsidized, people think that's a great idea. But guess what? Subsidized means the government pays for it and you pay for it anyway. So there's really time to get the business back into the free enterprise system, and nothing could do this like spent nuclear fuel powered fast reactors.
Okay. Hey, Stephen, we're getting zillions of questions.
Okay.
So we got to get back to some of our questions here.
Good.
And but I would like to point out a couple of things as we get into this and get into some of these questions. One of them is that one of the big advantages of having these microgrids is that you lessen the requirement on those large high voltage transformers that use to step power up and transmit bulk power across the nation. They're one of the most vulnerable aspects of our power grid. should we get an EMP and they burn out, those things take 18 months to get on the loading dock after you order them. If the grid's down, you're not even gonna be able to order them or get them or put them in place, and most of the people will be gone by the time you would get one. So you're talking about a very serious event there that this could help mitigate. Also, a lot of people don't realize our military bases currently are using civilian power for the by far almost all their power to run. And so they're going to be at a severe advantage running on the local civilian power, and they would have a huge advantage to having their own power sources, which this might do. Now, one of the questions come from, let's see, one of my guys in here, I think it's the Watchman. He was asking, what happens if you have a major pandemic and we lose a big sector of our population? Will we have enough people with enough technical expertise to run these things?
Well, that's the problem with everything. My opinion is if that happens, nuclear power reactors are the least of your problems. There's a lot of other things we need to run to keep our lives normal and the way we like them. But the truth is that a lot of the safety factors on these things take care of themselves. Yeah, you're going to need people to come in and take care of them, but with modern computers and stuff, they could go for a long time. In fact, some of these can be controlled from remote areas. A lot of the people are there for security, and they're there for maintenance, and they're there for troubleshooting if something goes wrong. So the initial reaction to that is, first of all, that would happen over a fairly long period of time. And if we're not smart enough to adjust to it, then we're just not smart enough. But I think the problems you'd have from a situation like we face it today, it's hard to find people to work in a lot of different areas. Although it hasn't shut anything down right now, it's still a troubling problem. But I think you'd have many, many, many more problems than what's happening with nuclear power if you had that situation hit you all of a sudden.
Steve, I think what you need to do is talk about the intrinsic features of this plant.
Yeah.
Why does it go into meltdown? You know,
They won't go into meltdown. I talked about that earlier. Yep, they are all individually convectively cooled, and they've been proven to be convectively cooled, which means that the stuff falls down to the bottom, heats up and pulls the heat up and cools it off the top, and then gets cold, goes back down. That's convectively cooled. And so whether you have, that's how the light water reactor designs work. There's a lot of things where they'll have a plug that'll take a reactor from there's reactor designs that are called liquid fuel that have the fuel mixed in with the coolant. That's either sodium or salt. And so those happen, all that stuff will fall into a container below the reactor, and it goes into a configuration where you can't have a fission. There's certain configurations that you can design where fissions are not possible. And so there's a lot of design aspects of this. The other thing about small modular reactors with sodium or chloride is they run at atmospheric pressure. So a lot of the problems you have with large reactors is they'll run it at 2000 PSI. Water has to be under very high pressure to transfer the heat that they need. So there's a lot of good features on these things that could work for us in our favor. And they're all built into the next generation reactors. But that's basically how it either counts on a configuration that won't go fissile, because if you have sodium, if it gets cool, it becomes a solid. That's the same way with salt. Table salt melts at about 500 degrees C, and if it goes below that, it's solid. So you can put it into configuration down below, it'll cool down itself and go solid. The ones with water will just keep convecting the water around it until it stops. And the solid fuel ones, what happens is the fuel, if it starts getting hotter, it starts separating. So it automatically shuts down its own fission products. And was proven in the desert in Idaho in 1986. They ran 2 tests on the solid fuel sodium reactor, and it shut itself down just as it was designed to do. So
the bottom line is, if there's nobody there to run it at all, it shuts down. It shuts down safely.
Correct. Doesn't really produce power anymore, but it'll shut down. Yeah.
People are worried about the human aspect and human fallibilities, and how people tend to make mistakes and screw things up from time to time. We do that. We all make mistakes. So, but this is a power plant that shuts down automatically in safe mode. If you don't have any external app. But that's the beauty of these other power plants don't do that. And the beauty of having one of these kind of power plants is that it could be used to make the bigger power plants that we already have safer by providing backup power for cooling and also to have the black start capability to restart the bigger plants. And we're not so reliant on the bulk power transmission our power grid today needs, which makes us more resilient against EMPs. I would point out, however, one thing. With all these underground facilities, what you still need EMP shielding. Maybe the EMP concrete would be the appropriate thing to use. And for those of you who don't know, I may cover that in a future video. There are some people in the Secure the Grid conference that Steve and I both support that are developing an EMP-proof concrete, which apparently is very good material. It just so happens that if the E3 wave travels underground with a huge surge of power, and the Russians were really astonished with some of their nuclear tests, how it really burned out a lot of their stuff miles from the detonation. So that's something we do have to watch out for. And that's one of the things that will get a lot of our transformers and a lot of your homes where these people are buying these little devices, which says, well, we'll shut everything to the ground. Well, it's going to come back up out of the ground and fry your house.
We have a lot of experience with the MP and the DOE and the nuclear program, because nothing produces a bigger EMP pulse than a nuclear power, than a nuclear blast, okay, nuclear bomb. And so we've worked with those for many, many years. The first one was in 1951. The last one in the United States was 1992. So we have a lot of experience with dealing with high EMP pulses and things to do. In fact, that's a well understood problem. Like you said, the idea is to design to it, and we just haven't had it happen, so nobody worries about it. And so until it happens, maybe then they'll worry about it. I mean, that's kind of the way we roll here.
Yeah. Now you talked about putting one of these at Eielson Air Force Base. It was just up the road about 100 miles from me when I was stationed at Fort Greely, and maybe not quite 100 miles. It was the closest next military base. And for a lot of those that don't know, Fort Greely had a nuclear reactor, and it was decommissioned. Reactor core was buried in the mountains, and my friend Ed Kiker buried that reactor core. He was a post-environmental officer and a geologist. So, I used to walk by that building all the time. It was just, maybe 100 yards from the building I worked in, that old reactor core. And there was really no concern at all in that area. But so the main thing with these dry casks is some people worry about how long the stuff stays radioactive. It does stay radioactive for a long time, but it's well contained within the ceramic of the dry cask itself. The biggest problem we have to worry about is these fuel rods when they're still real hot and can't be dry cast and can burn on contact with air. That's when the radioactive stuff could really spread out in the environment and get us all. That's what I worry about the most. And that's why I'm saying we need to harden our grid and take care of this stuff. It needs to be a top priority. I've got a lot of friends that say, shoot, with all the control from the government, we ought to just take the grid down. But I say, well, if you do, you're going to be underground because this stuff's going to fry you. So that don't work. We've got to get the grid hardened, and we got to take care of the spent fuel, because the grid may go down anyway due to the prospects for nuclear war and a solar coronal mass ejection. The sun's waking up. I don't know how much time we got to get these things going. I think we need to really get moving on it. And war drums are beating between us and Russia right now. Putin just threatened to take all our GPS satellites out with his new system. I got a video I just recorded on that, and I'm going to be posting that later tonight or tomorrow on this channel, and also my Galactic Greg's channel, because that's space war. And this is serious. So,
well, we do have something going for us, Greg. We got a lot of smart people in this country. Amen. And they've done a lot of amazing technology over the years. You remember the transistor that we invented here that got used by Japan to make a bunch of consumer products. But guess what? It came back here after that to make all the supercomputers we have in the world today. The same thing can happen from nuclear. We invented nuclear here, and we divide the early stages of it and led the world into this technology. Now, South Korea and China and Russia and India, and even now the UK and France are starting to get back in the business, and they'll control the world's business if we're not careful. Well, but I think the United States will find a way to get their leadership back in this area. And this whole idea of being able to use our spent nuclear fuel as a power source could be a huge jumpstart to it.
We've had a lot of people in here talking about thorium.
Okay.
What do you think about now? I've got a friend that's a nuclear engineer. He thinks thorium is a terrible idea because you basically have to make it be reactor grade in a particle accelerator is what he explained. It takes a lot of energy to get to that level. What do you think about thorium as a fuel? It's not a, you can't use it for nuclear weapons, apparently. So what do you, unless it's a dirty bomb, what do you think about thorium as a fuel source? This would be something alternate to what you're talking about. How do you think it falls in the competitive sphere of power options down the road?
There's a great benefit to thorium. There's probably 4 times more thorium than uranium in the Earth's crust, for one thing. India is going down that route because they have way more thorium than they have uranium. And burning thorium and burning used nuclear fuel work on the same principles, called the breeder reactor. And so what happens is it takes thorium out of the ground. That's an isotope called 232, adds a neutron, becomes the isotope 233, and then that turns almost immediately into uranium 233, which is fissile. So you're kind of like making your fuel at the same time you're burning it. And it's a very, very good concept. The only difference is we can't leverage the Congressional Nuclear Waste Fund and deal with our used nuclear fuel process by burning thorium. There are private companies. There's a company called Thorcon that has a very advanced design, but guess where their headquarters is going to go? Indonesia, because of our regulatory aspect here is so onerous that they're going to go build them in Indonesia and help them out. And so thorium does a great job, and it could be used. And in fact, if you mine natural, if you mine rare earths, thorium is a contaminant in those, and it's a real problem for mining rare earths because they got to take the thorium out. If we could find a profitable use for thorium, it would make it much more beneficial to take that thorium out, much more profitable, and then we can use more rare earths. And you know as well as I do, rare earths is cell phones and TVs and satellites and batteries and everything else depends on having any kind of storage device of the future depends on having rare earth materials. And so the things we use every day, we have to have those. So there's a lot of advantages of thorium, and I think it's a fine product. We can't leverage that used nuclear fund, the Congressional Nuclear Waste Fund, which is $45 billion, couldn't leverage that unless we find a solution to use nuclear fuel. So that to me is a big impetus to jumpstart the business. But I firmly believe that the private industry should run this. I don't think the government should run it. And so once they get private industry to a point where they can mass produce these things, I think they'll take it from there and make money. And so I think thorium's a fine way to do things. And there's actually smart people in the country working on it. And so if we get politics and the government out of our way, nuclear power would just kick ass in a free enterprise system like it did 50 years ago.
Well, to get politics out of the way, you got to use politics. Like it takes fire to fight fire. It takes politics to fight politics.
That's right.
And, that's why we reach out to the people here with videos like this. We're reaching out to the public. And I've started an organization called the Freedom Restoration Foundation. And I can post alerts on there that people and all kind of information, how people can contact the congressman. And we've got another friend who participates in our Secure the Grid teleconferences, who's been on my channel several times and also spoke at my last Power Grid Defense Conference. Command Sergeant Major Mike Mabee. He's got a website that goes into great details about things that people can do politically to get our grid secure. And a link to his website is on our one of our latest alerts on the Freedom Restoration Foundation website too. Go to freedomrestorationfoundation.org, and he's got tons of data in that website. I mean, it is chock full of all kind of data of things to do. And I got to get him back on his channel again. So, Steve, if you've got things that you're aware of that we should post to tell people what they could do to help enable this process to get these small modular nuclear reactors and the microgrids going and get them in a safer position so that we can have a safer infrastructure down the road. As H. Ross Pro used to tell Larry King, he says, Larry, I'm all ears. Stephen, I'm all ears. Help me out. If you got something, send me on this. We can get it up and we can post it to give people the tools they need to take action to keep our country secure. If there's anything else that you would recommend to, well, let me just ask, what do you recommend to our viewers that they do on their side?
Well, the first thing is stop talking nuclear down. If you don't know what you're talking about, don't just repeat things that you've heard. Try to find answers. I'm happy to answer any questions anytime. Greg's got my email address. You can email me your questions. I can point you to references and everything. We tend to listen to things that make us feel more afraid than we do to things that make us feel less afraid. And I don't know why humans do that, but they do. So the biggest thing is stop passing the information that nuclear is a horrible way to go. And the politicians are responding to what the public needs, at least to some degree. Another part of it is that we have this drive to get off of dirty fuel, natural gas and coal. And that's really not the evil. The evil is not having power at all. So if we push this system to its limits by trying to pass laws and make edicts that just go against physics and common sense, we're in trouble. And people are already starting to speak back about that. I've seen many more articles today on positive nuclear energy articles than ever before. And I think people are starting to realize that they do really have a role in this from their own perspective. But the big thing is don't talk down nuclear power if you don't know what you're talking about. Find out the facts. A lot of places to do that. Everybody can find a bad thing about something. Everybody can find a good thing about something. But there is really, when we talk about things, we got to talk about benefits as well as risks. And if you're hearing nothing but risks, then something's wrong. You're missing part of the story. So that's what I would recommend is they try to go out and get some knowledge. It doesn't take much to understand it. There's a lot of detailed things into nuclear physics, but if you're not going to build a reactor, you probably don't need all of those. But the basics you should understand and look at some of the facts that are out there. We haven't had a single accident with used nuclear fuel in this country, and that's been on the road since the late 50s. The Navy ships use nuclear fuel all the time. And so there has never, the people all worried about that, but there's no reason to be worried about it. Yeah, maybe you'll have an accident once in a while, but imagine you got a 30 ton reinforced concrete cask sitting on a truck and it wrecks. Well, it's not like having a chlorine truck or a gasoline truck where it breaks open and starts burning or starts poisoning people. You just have a crane come over and pick the canister up, put it back in another truck, and off you go. But people are trying to really hype people up because what if that was nuclear waste that's tipped? Well, if it was nuclear waste, you'd take a crane and pick it up and put it in another truck and go. And so these are really well understood problems. And there's a lot of smart people in this country who know how to do it. And I think we now start looking at the benefits and on how we're going to save our grid and keep our quality of life, because we have the best quality of life on the planet, because of these smart people and because of our free enterprise system. So the point is, if here's the scenario, if you're going to burn up the used nuclear fuel, we have more than 200 years worth of it sitting right in our reactor sites right now. You don't need 200 years worth of fuel. We need maybe 100 years at most, because next generation fuel will come. So we're all dead. 50 years to 100 years, we'll have fusion, we'll have space-based power or some other invention that hasn't even come along. So if you want to burn this use nuclear fuel, we're going to have to use electricity as fast as we can. We got cars coming on that may help us do that. But the more electricity used, the more we can burn it up. It could get to the point, I think, like cell phone service, long distance service. You and I, Greg, remember when our parents would whip our ass for making a long distance phone call. Now all kids have cell phones and make long distance phone calls across the planet. And that's because technology has come on board. We are sitting on the edge of possibility where we could have one monthly bill for all the electricity we can use. And yet that's horrifying to people who are making tons of money off of the current system. So if you citizens want a lower rate in electricity, you better get some competition going. There's an application in places for solar and wind and everything, but they're not application power in the entire system is not it. And if they're getting huge subsidies, guess who's paying that? The government's not paying it, you guys are. So just because money's raining from heaven doesn't mean it always will. And so I think we need to get back to our basics. Our free enterprise system built us and got us where we are. This is the cusp of something that can really get us going farther than that. And really all you have to do is just stop telling all your neighbors how terrible nuclear power is. And I'll be glad to answer anybody's questions about that.
Well, I think we should come back on here. You're at your brother's place right now in the future where you've got access to your files. And maybe you can just take us through some PowerPoint and show us what a small modular nuclear reactor actually is and how it works. That would be a good instructive follow-up to this video, to take people through that and maybe give people a second shot at some of the questions. There've been so many questions that streamed through here. I've only been able to hit the tip of the iceberg and pick a few.
I'm happy to answer the questions if you want to send them to me, and I'll even individually answer people's questions if they want.
What you could do is just log into the chat room later, or watch the video later and watch the chat room, and you can respond to them in the comments section.
Good idea. Yeah. Can I do that after the fact?
Oh yeah, you can do that after the fact.
Okay, send me the access information. I'll be glad to do that.
I'll send you a link to the video in an email. All right, so I think we're going to call it a night here. I've got to run real quick. So Stephen, I really appreciated your support here, bringing us this word about the small modular nuclear reactors and what it can mean and how it could be safer. Do you have any closing thing you'd like to say real quick?
Well, first of all, thank you, Greg. I just met Greg through the Save the Grid coalition that we have, and that's a system of a great many smart patriots that are really trying to help the issues in the United States come to fruition. But I've worked in this business for, like I said, I wasn't always educated at it. My undergrad's in EE, spent some time in the Army, but I always saw the value of nuclear power, whether I knew the details or not. But the more details I learn, the better it gets. And so just like with anything, learn the details. You don't have to study it and get a PhD in it, but just use your common sense and learn some basics and think for yourself. And if you do that with nuclear, like I did, you will find that there is really not much better system out there to help us with what we need to do, especially with energy. It's a God-given tool. One last fact I'll leave to you. When you split a uranium atom, you create an amount of energy that's 200 million electron volts. You don't need to know what electron volt is, but it's 200 million of those. When you burn one molecule of coal, you produce 10 electron volts. So you can split an atom and get 20 million times more energy out of one event than if you burn one molecule of natural gas or coal. So that's something to think about. That's why nuclear has such an advantage. It's a very compact way to do it. And despite what you heard, it's very, very safe. So thanks, Greg. I appreciate the time.
All right. And there's a lot of questions here. You might want to check them out and discuss with some of these people. Anyway, Steve, I appreciate it. Thank you very much. And I want you back on here to give us a more detailed rundown on these reactors, maybe in a week or two.
I'll be tired. Well, maybe in January you could do that because holidays are coming and all that.
Sounds good. So, January is great. Anyway,
so we'll get together and make it happen. I love to do this. Yeah.
Awesome, Steve. Thank you very much. Thank you everyone for watching. Thank you, mods. And I appreciate everybody that's asked questions. And a lot of people are challenging this, and that's fair because a lot of people have a lot of concerns about this. So we'll start addressing this more in the future. Thank you, everyone, and have an awesome, great night and a happy Thanksgiving. Bye-bye.